Hello, ladies and gentlemen. So I was going to fill out the last couple of examples from today's note. So this is from our note on the derivatives of ln x and ln g of x. So I'm just going to go back and refresh your memory on what we're talking about. So if we have f of x equals ln x, then the derivative of that is going to be 1 over x. And if we have the derivative of ln of g of x, then it'll be 1 over g of x times g prime of x. So that's the chain rule in effect there. And we did a number of examples here, and I stopped at number 2 and told you guys to give it a shot. And we don't know what tomorrow is going to be like, so I thought I would do it up right now so that everybody had it and our learning can continue. So when I look at this question, the first thing I notice is I better not use f of x because I've already used that. But I've got a product rule. There's g of x and there's h of x. So when I go to take the derivative, I'm going to have to take the derivative of the first times the second, and I'm going to have to add to that the derivative of the second, which is 1 over x, times the first. So that's going to give me 2x ln x plus x. And I can common factor that, and that'll give me, let's see, that'll give me a x bracket 2 ln x plus 1. And it asked me to determine all the values where the tangent is horizontal. So to get a horizontal tangent, that means that the f prime of x is equal to the slope of the tangent. So if a horizontal line has a slope equal to 0, then our derivative has to be equal to 0. So what we're going to do is we're going to equate these two. So what we're going to get is we're going to get x 2 ln x plus 1 equals 0. Now, this is the zero principle. You have a times b equals 0. So you have two things that multiply to give 0. And so what we're going to do is we're going to say either x equals 0 or 2 ln x plus 1 equals 0. To solve this, we're going to take 2 ln x and move the 1 over to the other side. We're going to divide both sides by 2. And I'm going to look at this and I'm going to say, gee, is that in logarithmic form or is it in exponential form? And the truth is it's in logarithmic form. It's log base e of x equals negative 1/2. So if I change that to exponential form, it'll be e to the negative 1/2 equals x. And that is one of my solutions. So my two solutions as it looks right now is x going to be 0 and e to the negative 1/2. Now, let's be careful. We have to go back and we have to make sure that whatever we have here can actually fit into these functions that we have. And lns are very finicky functions with their subjects. The subject of this ln is x, and we know that the subject of any log must be greater than 0. This is equal to 0. That's not greater than 0, so we need to omit this. And why? We say the subject of log must be greater than 0. And it's not. When we look back at the original equation, way up here, we notice that this x, no matter what we put in, needs to be greater than 0. Well, what about e to the negative 1/2? That is greater than 0, people. That's not negative. That is equal to e to the negative 1/2 is the same as 1 over root e. And that, in this case, is going to be our one and only solution for question 2. That is the only value of x where the tangent will be horizontal. All right, let's look at the second one. Same idea. The only difference is it's a little bit more complex. I got a g of x and I got an h of x. So my f of x is going to be the derivative of the first one. So it's 15x squared ln x to the 4 plus 4 ln x all to the 3 times the derivative of ln x, which is 1 over x, times the first, which is 5x cubed. So then we're going to put some things together. I'm going to get 15x squared ln x to the 4 plus 20 ln x to the 3, and it's all over top of x. Well, you know what? No, it's not. Lying. I've got x squared, x cubed over here. I've got 1x here, so that's going to leave me with simply x squared. Now, certainly I could rewrite that if I so wanted to, so it all looked pretty. It would look like this. And there's your derivative done, and you've simplified it, except have you simplified it enough for what we want to do with it? And the answer is no, we haven't. We want to set this derivative equal to 0. So what we want to do now is we want to take this value and we want to set it equal to our derivative. So we're going to get 15x squared ln x to the 4 plus 20x squared ln x cubed equals 0. And I can't do anything with that. I have to change it into the 0 principle. So I'm going to look at it, and I'm going to try to common factor out a 5. I'm going to common factor out an x squared, and I'm going to common factor out a ln x to the 3. That's going to leave me with a ln x to the 1 plus 4. So now I've got the 0 principle set up. I've got A, I've got B, and I've got C all multiplied to give 0, which means that either 5x squared equals 0, and I can solve that, divide both sides by 5, square root both sides, we get x equals 0, or the next one is ln x cubed equals 0. So cube root both sides, and you're going to end up with ln x equals 0. Well, now think about that for a minute. That is log base e of x equals 0. That's in logarithmic form. Let's change it to exponential form. E to the 0 equals x, and anything to the exponent 0 is 1. So that gives me another potential root. Notice I said potential because I got to go back and check into the original. And my last one is ln x plus 4 equals 0, in which case it's ln x equals negative 4. Remember, this is in logarithmic form. So if I want to change it into exponential form, it'll be e to the negative 4 equals x. And that is an answer. That's 1 over e to the 4. So now what happens is I need to check the validity of my answers, which there are 3. There's 3 potential answers, and I need to check its validity in this equation. So if I bring this down and take a look at it, let's see what'll work and what won't work. Well, I have the function, not the function, the argument of this ln is x. And we know that the subject or the argument of any logarithm must be greater than 0. So that means that I can't have this as an answer. So nope, we have to omit. The reason for the omitting is the subject of any log must be greater than 0. This is good to go, and this is good to go. So our 2 answers here are going to be x equals 1 and e to the negative 4. And those are our 2 answers. And I don't think they asked for the points. Nope, they just wanted the values of x. If they wanted the points, I'd have to plug them in and solve for that. Okay, ladies and gentlemen, that's it.